What is ODBC? ODBC is the unsung hero of the data world. It is the universal translator that allows a software application on one side of the digital divide to talk to a database on the other, regardless of which language either one speaks. Whether you are a developer, a data engineer, or a data analyst, understanding ODBC is key to grasping how modern data connectivity functions. What is ODBC and what does it stand for? ODBC stands for Open Database Connectivity. At its core, it is a standard application programming interface, API, for accessing database management systems, DBMS. The goal of ODBC is to make applications independent of database systems. Imagine you write a program that needs to pull sales data. Without ODBC, you would have to write specific code for Oracle, different code for MySQL, and yet more code for SQL Server. With ODBC, you write the code once to the ODBC standard, and the ODBC driver handles the translation for whatever specific database is plugged in. Who invented it and when? ODBC was created by Microsoft in partnership with Simba Technologies. It was first released in September 1992. It was based on the call-level interface, CLI specifications from the SQL Access Group, which later became an international standard, ISO/IEC 9075-3. While Microsoft championed it for Windows, the goal was always to create a cross-platform standard that the entire industry could lean on. Major updates and versions. Since 1992, ODBC has gone through several major iterations to keep up with the complexity of modern data. ODBC 1.0, 1992, the initial release, primarily focusing on basic SQL connectivity. ODBC 2.0, 1994, introduced support for 32-bit systems and improved cursor support for navigating data. ODBC 3.0, 1995, a massive overhaul that aligned with the ISO/IEC standards. It introduced features like descriptors and better diagnostic records. ODBC 3.8, 2009, released with Windows 7, adding support for connection pooling and streaming output parameters. Modern era. While there hasn't been a 4.0, the standard continues to evolve through driver-specific updates that now support cloud databases like Snowflake, NoSQL bridges, and big data platforms like Hadoop. What are the problems with ODBC? Despite its ubiquity, ODBC isn't perfect. Critics often point to these recurring issues. 1. DLL hell and configuration. Setting up a data source name, DSN, on a local machine can be a headache. If the driver versions don't match or the bitness, 32-bit versus 64-bit, is wrong, the connection fails. 2. Complexity. Because it aims to be all things to all databases, the API is incredibly dense. It requires a lot of boilerplate code to do even simple tasks. 3. The least common denominator problem. because ODBC targets a standard, sometimes the unique, high-performance features of a specific database, like a specialized PostgreSQL data type, aren't supported by a generic ODBC driver. Is ODBC slow? The short answer is no, but it can be. In the early days, ODBC was often accused of being slow because it added a translation layer between the app and the database. However, in modern computing, that overhead is measured in microseconds. ODBC becomes slow when inefficient drivers. A poorly written driver will bottleneck your data. Chatty communication, making too many small requests instead of batching them. Network latency. This is usually the culprit, not the ODBC protocol itself. In fact, many high-performance C++ and Python applications still use ODBC because it is closer to the metal than many modern, high-level web frameworks. Alternatives to ODBC. Depending on your tech stack, you might use one of these instead. JDBC, Java Database Connectivity, the standard for Java applications. It's similar in philosophy to ODBC, but built specifically for the Java ecosystem. OLEDB or ADO.NET. Microsoft's later attempts to move beyond ODBC, focusing on object-oriented data access. Native drivers. Direct libraries provided by database vendors, e.g., libpq for PostgreSQL. These are faster and support more features, but lack the universal flexibility of ODBC. REST APIs. In the cloud-native world, many modern databases like Snowflake or DynamoDB are accessed via HTTP or JSON APIs rather than traditional persistent socket connections. Why is it still so commonly used? If it's old and complex, why does it still run the world? 1. Legacy infrastructure. Thousands of enterprise ERP and CRM systems were built on ODBC. Replacing them would cost billions. 2. Tool support. Almost every BI tool, Tableau, Power BI, Excel, supports ODBC. It is the bridge that lets a business analyst connect a spreadsheet to a massive data warehouse. 3. Cross-platform reliability. It works on Windows, Linux, and Mac OS. It is a known quantity with decades of documentation. 4. The ecosystem. If a new database launches today, the first thing they build is an ODBC driver. If they don't, they won't be able to connect to the tools that businesses actually use. ODBC is the English language of databases. It might have its quirks and irregular rules, but because everyone speaks it, it remains the most effective way to communicate.